Hey students, it's Mr. Thayer, and since I'm not here today at school, I thought I'd help you with some sample work and your calculations for today. So before we get started on day 2 calculations, let's just make sure that you've got a scatter plot drawn that has the titles on the y-axis and the x-axis. You've plotted the points carefully, and you haven't played connect the dots. Instead, you've picked 2 points to draw a line through with your ruler representing your line of best fit by hand. Then you calculated your slope but with those 2 points and showed all of your work and uploaded the picture of your work. After that, you should be moving on to the next slide where you get a chance to find your line of best fit equation by hand. Okay, so our game plan for day 2, once you've covered your graph and slope work, is to work on question 3, finding that equation by hand, take no more than 15 minutes, move on to questions 4 and 5, and then 6 through 9. Take no more than 15 minutes. Those are suggested paces. You don't have to stick to that, but you do want to complete questions 1 through 9 in your packet here. So let's go take a look at how we're going to do some of these. So 1 and 2 we just spoke about. Number 3 is where you're going to utilize your skill set that you did on our last quiz in chapter 4. Take one of those points that you used to find the slope. Remember these? Pick one of these points and plug them into either point slope or slope intercept form and work your math to solve for your slope intercept form equation and upload your work here. After that, let's move on to question number 4 and 5, where you have to use the graphing calculator. So that's what I want to help you with today. You can use the graphing calculator, or another option is to use Desmos. So I'm going to take you to Google, and I'd like you to just Google on your computers Desmos graphing calculator. It's the first link that shows up. On here, we are going to hit the plus button, and we're going to select table. Here, I want you to take a moment and pause this video, and then resume it after you've typed in the values from your table from this slide right here. So go ahead and pause and type in those values in your table. Okay, if you resumed, you've got your values in your table. Now it's time to have Desmos come up with that line of best fit for us. So click the plus button one more time, and this time click expression. For expression, type the following in to get your line of best fit equation. Y1 equals mx1 plus b. Now I'm getting an error because I hit equals. Instead of the equal sign, we need to select that little squiggly sign above the tab button. So shift, press that button. Now we've got our information right there. Looking here very closely, you have your answer right here, r equals 0.9858. That's your answer going back to your slides here to number 5. So write in that value in number 5 right here from your Desmos graphing calculator. Your equation, the most important parts of this, the parts you're going to use in your calculator equation. Here's your slope. Now this is for my data, so yours will be different. 6.2 is going to go in for M. 8.9, that's going to go in for B. Okay, that will go in box 4. So again, in Desmos, this calculator work gives you the pieces to your equation. There's your slope and there's my y-intercept. So my equation is y equals 6.2x plus 8.9. So I would type that into box 4 right here. Okay, this is very important. Again, my R value that I saw from the screen right here was 0.9858. Okay. We're going to use this equation several more times. Let's go on to the next slide here together. It says, based on your R value from number 5, is it going to be reliable? Well, guess what? If your R value is close to the number 1, it is going to be reliable. So to put simply, if your R value is close to 1, we're going to put, we have a strong positive, because it's a positive number, your data is flowing upwards, linear correlation. So yes, we predict our equation will be reliable or accurate. Okay, so now let's use our equation. So that equation from number 4, we're going to use this several times. So I'm just going to screen grab this so I can paste this several times over throughout this video, because we're going to use it in number 7 here. So using this equation for me, because this is my equation, yours is different, we're going to do number 7, which says use your equation to predict what distance Barbie would fall using 50 rubber bands. Now think about it. Rubber bands, is that the X or Y variable? If you said the Y variable, you would be incorrect, because if you remember, the Y variable is the distance measured in centimeters. It's the X variable. So you want to answer number 7, plugging in 50 rubber bands in for X. So for me, I would show my workout writing 6.2 times 50 plus 8.9. Snap a picture of my answer that I get for that and predict Barbie will fall a certain amount of centimeters when 50 rubber bands are attached as her bungee cord. Don't forget to give credit to whoever's work you uploaded. All right, in number 8, we're also going to use our calculator equation. Remember, yours is unique. Don't be using my numbers. So you can copy and paste that here so it's ready to go. This time, we're going to predict how many rubber bands we would have to attach to fall a distance of 150 centimeters. Again, falling a distance of 150, is that the X or the Y variable? If you said Y variable, you're correct. Distance fallen is Y. So 150 is going to go in your equation for Y, and now work out on paper solving for X. And of course, you can't have a partial rubber band. So if you come up with 35.3, round it down to 35. So work out your math, pause the video, and resume when you're ready to move on to question 9. So you've made it to question 9. This is it. You are trying to get Barbie as close to the ground from the top of the stairwell without any part of her touching, not a single hair follicle. So that means using your equation one last time, you're going to make a prediction with 465 centimeters as the goal for her to fall from the stairwell. Again, is that Y or is that X? Remember, X is rubber bands, so it must be Y. 465 centimeters is going to replace Y. And one more time, solve for X. That value you get rounded to the nearest whole rubber band of your choosing. Again, if you get 44.6, you can choose to round it to 45 or round it down to 44, up to your team. That is the amount of rubber bands you'll create for the big bungee cord for the jump on Monday. So take your time solving your equation. Everyone solves, remember, and then upload someone's work to this slide, and be sure to give credit and make your prediction over here on the right. Okay, if you've done all of 1 through 9, it's the end of the class period. It's time to look over your work and make sure you've got all the pictures uploaded where necessary and your whole table's filled out. So go back to the beginning and make sure you've got your roles. Of course, your team photo should be in here. This whole table should be filled out. You should have a beautiful graph right here in the gray spot. This table completed. And of course, your points and your slope work, your equation work by hand. And then you moved into, after your equation work by hand, you moved into the calculator work using Desmos. If this is the advanced math class, you can use your graphing calculator or Desmos. And then you've got some prediction work using your equation. Don't forget to give credit. Each person in your group should share their work at least once throughout this presentation. You made your prediction, and this slide is something we will talk about on Monday for the big drop day. If you have time, feel free to create your bungee cord here in class, and then take a sticky note, write your name on it, and wrap it around that bungee cord, and either set it on the window ledge or set it on my desk. It would help if you also wrote your class period on there so you could easily find them. Good luck, students, and remember, this is the goal, to get as close to the ground as possible. If I won't see you on Monday, have a great break. Otherwise, the rest of you, I'll see you on Monday for Barbie Bungee Drop Day.